Hi everyone, my name is Olivia Atlas, and my project looks at how the VA can improve electronic health their electronic health record or EHR deployments. So recent rollouts have struggled with the same issues, which include clinicians completing trainings, but they still struggle at go live deployments. Incidents repeat across multiple deployment sites, and leadership still having to make decisions without clear risk signals. So, I was able to design three small research spikes that can explore how AI could help detect risks earlier and support better deployment decisions. So, these three research spikes each address a different gap within how EHR deployments are actually evaluated. So, the first explores whether simulations can reveal how clinicians actually perform under pressure. The second analyzes past deployment incidents to identify patterns that can signal future risks. And the third focuses on helping leadership to make clear go live decisions using those insights so they won't have to feel more so of the political pressure. So, for the very first spike, this focuses on how clinicians can interact with the EHR system. So, instead of relying only on training completion, clinicians will run through short simulations that include realistic workflow challenges. The system observes how they respond, uh, including accuracy, their response time, and escalation behavior to see whether those signals better predict problems after they go live. This is something that I t- took from a cybersecurity standpoint of phishing simulations on how many organizations use phishing to detect uh, just different behavioral responses from their employees. So, for our second incident spike, this focuses on learning from past deployments. Every VA rollout generates incident reports, help desk tickets, and system logs. So, this spike uses machine learning to identify patterns in that data so planners can recognize warnings, warning signs before the next deployment actually begins. For this spike, the third spike, which focuses on decision making, it brings the signals from the first two spikes into a simple governance dashboard. And this can help leaders see indicators, simulation performance, and they'll be able to run what if scenarios to better gain understanding of deployment risk before making a final decision. This is my use case decision matrix. And this slide shows how these ideas can necessarily evolve. Each spike starts small using existing data, simple experiments, and if the signals prove useful, the models will be able to be refined and eventually combined into a much larger system. This slide shows how the project develops over time. It starts with the core deployment problems, then moves into the focused research spikes, and from there into possible implementation paths. So the AI tools were able to help me organize ideas and help me see how separate parts could eventually connect. But the main goal, of course, stays the same and testing out the small ideas first before scaling into anything much bigger. So, in summary, these three spikes form a layered approach. The first looks at clinician behavior and simulated EHR workflows. The second analyzes patterns from past deployment incidents. And the third helps leadership to bring those signals together when making go live decisions. So, essentially, what makes all of this possible is that the VA already has most of the data that is needed, so we won't have to start over from scratch. We will have their incident reports, their system logs, and their training activity. The difference is just now using that information proactively rather than after a problem occurs. So, advances in machine learning and simulation tools also make this much easier to test these ideas through small experiments before building larger systems. Using together these spikes show how AI can help organizations move from reactive troubleshooting to more proactive deployment planning. Thank you for your time.